reversing the nodes in the given linked list. So reversing a linked list by reversing the direction of links between two nodes. So here the given list is having four elements: A in the 101, B in the 102, C in the 103, D in 104. So here the head is having the address value 101. So and tail is having the pointer 104 address. So now we want to reverse the list. When we want to reverse the list, the first node will become the last node, first node will become the last node, and the second node will become the last second node, and like that the last node will become the first node head. Okay, so D will become the head, and here A will become the tail. So address of the A is here 101, address of B is 102, C is 103, D is 104. So now head is having the address 104, tail is having the address 101. Okay, so like this we have to change the address. Now when we are changing the address, the next field of all the data points has to be modified. You look at this. So next field of all the data points has to be modified. So here a in the reversed linked list, A next field is null, but in the uh, given list A next field is 102. So here which is null. Like that the D next field in the given list is null, but here we have to make it as a 103, right? Like that in C the next field is 104, but here it will be a 102. For B the given list is having 103 next field, but here we have to make it as a 101. So how to do this, right? So we have to make use of three structure pointers P, Q, R. Then at any moment Q will point to the Q will point to the node next to P, node next to P, and R will point to the node next to Q, node next to Q. Okay, this one. Then next iteration P will become the Q, right? So the Q is assigned to the P, R is assigned to the Q. Okay, so R is assigned to the Q, right? The P is assigned to the Q is assigned to the P, Q is assigned to the P. So at the end we will change the head to the last node and the tail to the first node. So that's what we have to make here, right? So we have to make like this. Okay, so here head is the last node, the tail is the first node. So how to do this? Okay, so here example is given, as I explained you in the previous slide. So here we are using the temporary variables current and next, and also one more previous we will see in the code. So finally the tail is having the uh, tail is the first node of the list and head is the last node. So now we changed everything, right? So here uh, the one not the address is changed, address is changed in the all nodes. Okay, now I will draw one list simply, then I will make you understand. I will take node 1, node 2, node 3. So node 1 is 101, node 2 is 102, node 3 is 103. So here head is pointing the 101, right? Then 102 is address of first node, 103 is address of second node, null is address of third node. Okay, the tail is pointing the 103, which is tail. Now I want to reverse it. For that I am passing the head. Now first I am checking head equal to null or not. No, head is having the value 101. So the list is empty. This block will not execute. Okay, because my head is 101. My head is 101. Now I am creating one variable previous. Okay, I am creating one variable previous, and the head is assigned to the temporary variable current. Head is assigned to some temporary variable current. So now this is head is assigned to current, and I am creating one more variable next. So both are null values. Previous also null, next also null. Now I am checking current not equal to null. You look at this, current is not equal to null. What is the current value now? Current is 101. 101. Current address is 101. So here the 101 is not equal to null. Yes, it is true. If it is true, I am assigning current dot next. What is the current dot next? Current dot next is 102. So 102 is assigned to the variable next. So this 102 is assigned to the variable next. Then current dot next is assigned with previous. So what is the previous? Previous is null. Okay, previous is null. So now the current dot next is 101. I will draw the list like this. So now the 101 current dot next, okay, is making as a previous value. What is the previous value here? Null. Okay, so null is written in the 101 next field. Okay, 101 next field. So current is 101, 101 next is previous. So null is written. Then current is assigned to the previous. Okay, current is 101. So this is assigned to the previous, right? Then next is assigned to the current. So which is the next? Next is 102. So this is assigned to the current. Okay, 102 is assigned to the current. Again, this is while loop. While loop is coming back to the iteration number 2. Okay, iteration number 2. So here current value is 102. 102. So 102 not equal to null. Yes, it is true. It is true, right? Now in the second iteration, the value of current dot next. What is the current dot next? 103. So 103 is assigned to the variable next. So 103 assigned to variable next. Then now current dot next. What is the current dot next? Current is 102. So I will draw one node here, current node. Current node is the memory address is 102. What is the current dot next? Current dot next is assigned to previous. What is the previous now? Previous is 101. Okay, in the second iteration, previous is 101. The 101 is assigned to current dot next. This is the current dot next is assigned to 102. So it will, the link will be created to the node 101. Then now the current value, which is the current is 102. Okay, current is 102. 102 is assigned to previous. So this will become previous. Now previous is updated. Now which is the next is 103. So 103 is assigned to current in the second iteration. So right now current will become the 103. Then in the next iteration, right? So here the current value is 103. So 103 in the third iteration not equal to null. So yes, 103 is not equal to null, right? So which is coming inside the block. So current dot next, which is the current. Now current is 103. Okay, already updated in this statement. Current is 103. So this is the current now, right? So current is not null. Yes, true. So current is dot next is null. Current dot next is null. So null is assigned to next. Okay, null is assigned to next. Right. Then now previous, what is the previous node? Previous is 102. So 102 is assigned to current dot next. I will draw one node. This is current. Okay, current is 103. 103. So current dot next is, okay, current dot next is previous. So previous is 102. So I am writing 102 in the address field. If I write the 102, the link will be created to the 102, right? Then now what is the current is? Current is now 103 actually. So 103 is assigned to previous. So this is previous now. This is previous now. Then next, what is the next here? Null. What is the next here? Null. So now current value is updated. Yes, null. Current value is updated. Yes, null. Then again coming back to the while loop. Now the fourth iteration, current is null. Null not equal to null, false. Okay, current not equal to null, it is false. It will come out of the loop. It will come out of the loop. Now the previous, which is the previous in the list, look at here, this is the previous. Okay, this previous is assigned as head. So head pointer will be created, right? The head pointer will have the previous is 103. So this is pointing the 103. So now you look at that, the list is created in the reverse direction. So here the 103 becomes head, the second node is 102, the last node is 101. So this is the way to make the reversing of linked list. Thank you.